So one important aspect of AI is that we should be able to trust it. Whatever decisions we make, we need to deploy them and perhaps understand why we are doing it. So we have three experts here that can describe technologies that we have developed for this purpose. So Xin, why don't you tell us about how we can measure and understand uncertainty in AI?
Yes, so recently we have developed a new technology called RIO, which is able to provide additional uncertainty information on any existing models. And also at the same time, RIO can improve the prediction accuracy of these models. So one advantage of RIO is that it can be directly applied on top of any existing or pre-trained models without any retraining or modifications to the original models. So the main idea behind RIO is to construct an approximate Gaussian process that can learn the prediction residuals of the original model. And this Gaussian process is utilizing a new composite kernel. We call it IO kernel. So the IO kernel is actually using both the inputs and outputs of the original model so that our uncertainty estimation is much more reliable. And we have validated the effectiveness of RIO on some data sets. And we also try to apply RIO to some real world applications. One example is the age estimation project. So the original neural network model only returns a single value for age estimation. But after applying RIO, we can also get some confidence bounds at different confidence levels for age estimations so that we have a better sense of what can be the possible outcomes and what is uncertainty of these predictions. So all this information is actually very helpful to improve the trustworthiness of our AI models.
Yes, that sounds great. So to understand where AI is confident and where it isn't allows us to be more trusting about what we deploy. But sometimes we would also like to see what else is possible other than what the AI suggests. So maybe Olivier, you can tell us about that technology.
Yeah, so we've also developed what we call a scratchpad, which is a tool that allows the decision maker to test things out. So when the AI makes a recommendation, the decision maker can actually go to the scratchpad and test the recommendation and maybe try something slightly different, try something else, because maybe the decision maker has some additional pieces of information that was not used when training the system, or maybe the decision maker just want to see what the other solutions are and just want to make sure that this is really the decision he or she wants to go with.
Yeah, that's great. It's very useful. People like to convince themselves that what they have is the best possible solution, and that scratchpad allows you to do it. But also in some cases, it's not enough to just have a black box, but the decision maker might want to see where the decisions are coming from. How did the AI come up with them? So Hormoz, maybe you can describe technology for doing that.
Yes, as you mentioned, black box model have their own advantages, but sometimes, we can always tame them with uncertainty estimation and analyzing what if scenarios. But there are cases that transparency is the #1 priority. So for example, in medical applications, when the expert actually want to trust the system about the diagnosis, or like in finance, when there are legislation that we need to comply, and like in insurance, the same thing. Evolving the rule set not only can do those tasks, but you can actually read the rules and understand why AI is suggesting what it's suggesting. And these models, they're kind of intrinsically explainable, and therefore very suitable for to satisfy those needs. And there are other things that you can gain from analyzing those rules, like like you can gain some scientific knowledge, or you can detect bias in your training data, and all sorts of things. So it has its own advantages in trustworthiness of the AI.
Yeah, so these three techniques, RIO, Scratchpad, and rules at evolution, should make it easier to trust the AI, and therefore easier to work with the AI, and also apply it to many more tasks.